Okay, in an earlier part of the question, we have already calculated the balance length to be Pj. So before we make the connection, the potential difference across Pj is 1.2 volt, thanks to the 5 volts battery. And the potential difference across Rs is also 1.2 volt, thanks to the 1.2 volts battery here. So when we make the connection, we got 1.2 volts across here and 1.2 volts across here, so they're already matched. So the battery here doesn't have to do anything, it just relaxes. And that's why this is called the null deflection point, because there's no current flowing through the secondary circuit here. Okay, say we now make the tap at X instead. What's going to happen? To answer this question, we've got to ask ourselves, what is the situation like before the connection is made? So before the connection is made, the potential difference across Px is less than 1.2 volt. Because across Pj is 1.2 volt, so across Px has got to be less than 1.2 volts with a shorter length of wire. So this is less than 1.2 volt, but across Rs is 1.2 volt. So when we make the connection, something must happen, because if this battery doesn't do anything, then the PD across Px is lower than the PD across Rs. But Px and Rs are connected directly, so the PD cannot be different. So what's going to happen is that the 1.2 volts battery will supply a current into the potentiometer wire. So now we have currents coming from the 5 volts and the 1.2 volts going into the potentiometer wire. So we have increased the amount of current flowing through Px. This is going to increase the potential difference across Px towards 1.2 volt. The magnitude of this current is such that the PD across Px is exactly the same as the PD across Rs. Okay? What if we tap at a point Y instead? So what's going to happen depends on what's the situation like before the connection is made. So without the connection, the PD across Py is larger than 1.2 volt. So the PD across Rs is 1.2 volts, right? So when we make the connection, something must happen. Because if nothing happens here, if this 1.2 volts battery doesn't do anything, then the PD across Py is larger than the PD across Rs, but they are directly connected. The PD must be the same. So what's going to happen now is that instead of this battery supplying a current, it's actually going to take in a current. So the current that's coming from here, part of it is going to be diverted into this branch here. So the current comes this way, does a split, recombines, and goes back there. So we have reduced the amount of current going through section Py of the potentiometer wire. With a smaller current, we are going to reduce the PD across Py towards 1.2 volt. Again, the magnitude of this current is such that the PD across Py and the PD across Rs are equal. They will match. So, whether you tap the potentiometer wire at J or X or Y, the PD across that section of the potentiometer wire is always equal to the PD across Rs. This has to be so because there's a direct connection between those two pairs of points. What is special about the balance length and the null deflection point is the PDs are matched without the 1.2 volts battery having to supply any current. Okay, I hope I've made it clearer for you. Okay, ta-ta!